Okay, in this presentation we're going to explain how to use your instant ballistics chart to determine the distance to your target. Okay, first of all, we need to know whether you are dealing with a first focal plane scope or if you have a second focal plane scope. Now you might already know the difference, but if you don't, if you will look through your scope at the reticle or the crosshairs, when you change the magnification on your scope, if those crosshairs remain the same size as you're changing the magnification, then you have a second focal plane scope. And the problem with the second focal plane scope is that the range estimation feature is only going to work on one magnification setting. Usually it's the highest setting on the scope, or it might be at 10 power. You have to check the literature that came along with your scope. So those crosshairs, those that mil dot reticle is only going to work at a specific magnification with a second focal plane scope. Now with the first focal plane scope, when you look through the scope, you change the magnification setting on your scope, you're going to notice that the mil dot reticle changes size along with the magnification as you're turning the magnification knob. So with a first focal plane scope, the advantage is you can use that scope for ranging and also for holdover and Kentucky windage, and you can use that scope regardless of what magnification setting you have it set on. Alright, this is what you're going to see when you look through your scope. This is your mil dot reticle. And right now we're going to determine the distance of an 18-inch diameter bullseye target. And let's assume that looking through your scope, this is the view you see. You see the 18-inch target, and you're going to push it right up against the edge of your mil dot reticle, right up against your crosshairs there, so you can measure the size that it subtends in your scope. And you can see here that this 18-inch target subtends about 1.7 mils. The distance in between each of those dots is 1 mil. And 1 mil is a conical type of measurement. It is 3.6 inches at 100 yards, and it's 36 inches at 1,000 yards. So it spreads out in a cone, and that's something important that you can remember. And just as another note, let me say that it's usually better to measure an object on the vertical axis than it is to measure an object on the horizontal axis. And that's because sometimes the object could be rotated a little bit. If it's rotated, then obviously your object is going to appear to be a little bit smaller than the actual width. So it's better to measure the height of an object if you can. Okay, here we see a representation of the parts of the chart that are relevant to this part of the discussion. That is where we are trying to determine the distance of an 18-inch diameter target. And you can see here a funnel-shaped line off to the right of your reticle, and it goes down in a curve there from the 300-yard mark. Now each of these lines coming off to the right represent a holdover line for each 100-yard increment. So your scope in this system should be zeroed for 300 yards. And above the 300-yard mark you see, or I should say above your crosshairs, you see a mark for 100 and 200 yards. And then below your crosshairs you see 400 yards, 500 yards, 600 yards, 700 yards. And just above the 700 yard mark you see the number 18, and that is to remind you that this funnel is used to determine the distance of an 18-inch target. Now we're going to drop a representation of the target that you saw earlier on top of the representation of the chart. And obviously you're not going to be able to do this in the field. You're going to have to determine the size of the target through your scope. You're going to have to measure the number of mils that that target subtends, and then you're going to have to look at your chart and determine where on that funnel that target would fit into your chart. So for this instance, the target is going to fit right at 300 yards. You can see that the maximum diameter of your target fits at the very tip of that funnel line, right where it intersects the 300 yard mark, which is also the zero of your rifle. It should be where your rifle is zeroed. So you can determine right there that this target, this 18-inch target, is at 300 yards. And that's where you need to aim to hit that target, is at the 300 yard marker, which is where your rifle should be zeroed. Okay, we're going to move to another example. This is also an 18-inch target, but you can see that this target appears to be much smaller. It's still 18 inches, but it appears smaller in your scope. This one might be 1.1 mils. Okay, so if we drop that target right into our chart, you can see that the maximum diameter of that target just touches the funnel right around the 450, 460 yard distance there. You can see that the target ends up being right between 400 yards and 500 yards in this example. Okay, we have one more example for an 18-inch target. And this one appears to be quite a bit smaller. It's still 18 inches, but it's much further away. And this target looks to be about 0.7 mils in total width that it's subtending here on your reticle. And if we drop that target onto your chart, you can see that it's right at the 700 yard mark. So if you use your holdover for 700 yards, you should be able to make a good solid hit on this target. This target should be right at 700 yards. Now, of course, you're not actually dropping the target onto the chart, but we're using this for illustration purposes. Okay, now we're going to move to a 9-inch target. It's much smaller, obviously, but in this example, this 9-inch target looks to be reasonably close. It's over 1 mil. That might be 1.1 mils. In this frame, we see the relevant parts of the chart to allow you to determine the distance of a 9-inch target. These are the vertical lines that you see on the left side of the reticle. Each of those lines, the height of those lines, are where a 9-inch target subtends at that specific distance. And if we drop the previous target on top of your chart, you're going to see that that target is much bigger than the line for 400 yards. You can see on the left there the line For 400 yards, number 4. The next line is 500 yards, number 5. Well, your target is much bigger than that. So this target is probably 300 yards or maybe even closer than 300 yards. Okay, here's another 9-inch target, and this one is quite a bit further away. This target might be 0.6 of a mil, would be my guess. And if we drop that target onto your chart, you see that it's right between the 400 yard mark and the 500 yard mark. If you look at the height of those lines, the tip of those lines off to the left, it's right between the 400 yard and the 500 yard mark. So this target is about 450 yards. Okay, now we're going to switch to a 24-inch target, which is much bigger, obviously. And this target, through your scope, this target is about 1.7 mils in diameter. So this shows the relevant part of your chart. Once again, we're using the lines off to the left side of your reticle, but this time we're using the horizontal element of that chart to determine the distance of a 24-inch target. And we drop our 24-inch target onto those lines on the left side, and you can see that that subtends exactly at the 400 yard mark. So this target is 400 yards away. And now we see another 24-inch target. This one is quite a bit further away. This target is subtending about 0.8 mil in your scope. And by dropping the previous target onto your chart, we see that now across the horizontal line, this target ends up right between the 800 and 900 yard mark on your chart. So this target is about 850 yards away. This is a 24-inch target, and we're measuring across the horizontal now. And now we see a 12-inch target. Now it's pretty easy to determine the distance of a 12-inch target. Okay, so we drop the 12-inch target onto our 24-inch part of our chart, and you're going to see that it subtends the 800 yard mark. Well, it's pretty simple. 12 inches is exactly half of 24 inches. So in this case, this target is actually 400 yards away. It's not 800 yards away. At the top of your chart, you're going to notice this formula. Target size in inches times 100 divided by 3.6, which is the number of inches in a mil at 100 yards, divided by the number of mils equals your range. So you can use that formula to determine the distance of any target if you already know the size of that target. So let's try the formula for the last target. We determined that it was a 12-inch target, and we determined that it was at 400 yards. So if we take 12 inches times 100, we have 1200. 1200 divided by 3.6 equals 333.3. And if we take that 333.3 divided by 0.8, if you remember the size of that target as it was shown in our scope was about 0.8 of a mil. If we divide that, we end up with 417. So 417 yards is what we get by using the formula, and that's not too far away from 400 yards. So actually you might want to use a couple of different methods to determine range. Of course, if you have a laser rangefinder, that's the preferred method, but you can always use one of these analog methods to go back and double check the number you get on your laser, because it may not be, sometimes you get an erroneous number. And you can use a couple different methods as I've shown you here to determine the range and see what the average is. Okay, if we look here at our 9-inch target again, this is our 9-inch target that was at 450 yards. And it looks like it subtends about 0.6, maybe 0.55 mils. And if we use our formula again, 9 times 100 equals 900. 900 divided by 3.6 equals 250. And if you take 250 divided by 0.55, you end up with 455. So we had 450 yards. By using the formula, we get 455. That's really, really close. Now, we would have been off quite a bit if we would have used 0.6. But when you're starting to deal with smaller targets, you have to be really, really precise in your measurement of their size along your mil-dot reticle. Okay, so this time we have a 24-inch target. This is the 24-inch target that was at 850 yards on our chart. And this appears to be about, I'm going to say about 0.8. And this one is at 850 yards. So this is about 0.8 of a mil by my estimation. We run it through the formula, 24 inches times 100 equals 2400. 2400 divided by 3.6 equals 666.6. 666.6 divided by 0.8. We measured the target to be 0.8 mils. And that equals 833. So I had 850 by using the chart. And if we use the formula, we end up with 833. So if we ran it through the formula and also using the chart just to eyeball it, I would probably take an average of those numbers. I would set my scope for about 841 yards, something like that. 842 yards maybe. Thank you for watching the range finding tutorial, and thank you for your interest in Instant Ballistics products.